Hey guys, welcome to the level 2 calculus paper from 2021. If you're joining us for the first time, the way this video works is I go through each question and tell you guys what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, have a go on the question by yourself, and then unpause the video just to see how far you actually went. And then you get to compare your answers with mine. Cool, so let's get started. That's right. How can I forget this? Um, I know a few people have been asking me in the past how they can actually support me or this channel. One thing I did do earlier this year is start my own store. You can find it on Instagram as well as on Facebook, Infinity Plus One Store. Just making a few things, making signs, cake toppers, and things like that, whatnot. So if you need anything like this or know anyone that needs anything like this, yeah, just shout my name out to them and just drop us a follow on Instagram. Much appreciated. So, without further ado, let's get started. All right, guys, so let's start with question one here. Question 1A, what we've got is a function, and we've been asked to find out what the gradient is at x is equal to 3. So really, we're looking for f dash of 3. This is what we're looking for. So one of my habits is that I always write down f of x first. I mean, you guys don't need to do this, but it's just easy for me to kind of like write down what it is, and then I'll just differentiate it. So f dash of x is going to equal 12x squared minus 4x and minus 7, and of course the constant is going to disappear. I don't have to worry about it. So f dash of 3 equals 12 times 3 squared minus 4 times 3 minus 7. Of course, I can just punch this straight in the calculator. So what do we got? Menu 1, we've got 12 times 3 times 3 minus 12 minus 7, and this gives me 89. When I look at the answer schedule, I'm going to show you guys the answer schedule real quickly. Just with calculus, you've got to show the differentiation function as well. So derivative, you've got to do the derivative as well. So if you guys have a look, what do we've got? We've got derivative found and gradient evaluated. So you got to actually do both of them to actually get the achieved grade. All right, so we are going to get an achieved for this, and we go to question 1B. All right, so question 1B, what do we've got? For this cubic function, find the equation of the tangent to the curve at x equals to 2. So we've actually got to figure out what the gradient is at x equals to 2. So we're going to figure out what f dash of 2 is first. And then we've got to come up with the equation of it. All right, so it's a two-part question. So the first part I'm going to work out is I'm going to actually work out what the gradient is. So we've got, what have we got? Half x cubed plus half x. So we're going to differentiate this. So f dash of x is equal to, now 3 times half is just 3 over 2, x squared, and then half x just differentiates to half. So our gradient at 2, so f dash of 2, equals 3 over 2 times 2 squared plus half. What do we got? We got 3 times 4, that's 12. We've got 6. So 6 plus half, which equals to 6.5. Now this is what the gradient is. Now we need to find the equation of the tangent to the curve. Now if you want to find the equation, remember for the equation you need a gradient, you need the x value, but you also need the y value as well. Now we've got the gradient, right? Because what is our m? Our m is this right here, 6.5. That's what the gradient is. We also know what x is. X is equal to 2. But what we don't have is, we actually don't have y. And the way we're going to figure out y is by actually working out what f of 2 is. So we've got another step here. So f of x is half x cubed plus half x. So we're actually working out f of 2. So we're going to get 1 over 2, 2 to the power of 3, plus 1 over 2 times 2, which actually gives us 4 plus 1, which is 5. Okay, so this right now, this 5 is our y value. So now we go to the equation of the tangent, which is the straight line equation where you have y minus y1 equals m times x minus x1. So with that in mind, we've got our gradient, which is, oh, sorry, wrong color I'm using. Where is it? The yellow is going to be our gradient. We also have our x1. Now you might be confused. It's like, why am I using x1 as green? Because that's the value, remember that? Because when in our straight line equation, we're always going to have like y equals something x something, right? So that's just something to remember. And if you forgot how to do this, go back to level 1 TEG, have a look at straight line equations, and it should come back to you. All right, so we've got y minus 5 equals f of 2 is the gradient is 6.5, x minus 2. So we just need to expand the brackets. We're going to get 6.5x minus 13, and we're going to rearrange this. So we got 6.5x minus 13 plus 5, and that now we can simplify it to be 6.5x minus 8. So as you can see, multiple parts to this particular question. Grades-wise, correct equation of the tangent is going to get you a merit. A correct derivative gets you an achieved, which is right back here at the earlier point of this question. All right, so there's a lot happening in this question, as you can see. I mean, but the thing is, at the end of the day, it is just an equation of the tangent question, which means you have to work out all of these things in this red box here, which is you've got to work out the gradient, you've got to calculate the y value or the x value, and then you finally get to the equation of the tangent. All right, so let's go to question C, part 1. Okay, so with this question, what we have is we've got the number of viewers over a period of time. What else? So they're asking us to find the rates of change of daily viewers with respect to t when the number of daily viewers is 3520. All right, so what they're asking for is, it's kind of going to be tricky for me to kind of write this, but like basically what they're asking is, first off, we've actually got to figure out when the viewers are going to hit 3,520, right? Once we get that number, then we've actually got to figure out what the, what do you call it? What the rate of change of daily viewers is. So we're basically looking for, I'm just going to see, okay, let's say it's something like this, right? Not V of t. We're going to put this as like V of, I don't know, T1, for example. All right, because we don't know what that T1 is, like when that viewers is 3,520. But what they're asking, the question's asking for is what is V dash of T1? All right, so that's what they're asking there. So it's another two-part question. We've actually got to figure out what T is first. Once we figure out what T is first, then we can actually go and differentiate and then substitute and solve. So our equation here, if you look at the original equation for the number of viewers, we've actually got negative 11t squared plus 528t. So that's that original equation for the number of viewers. And we're going to put that equal to 3,520. All right. So the next part is negative 11t squared plus 528t. I'm going to bring this number to this side, to the left-hand side to make it minus 3,520. And I'm going to put this all equal to 0. Now, the reason I want to do this is because what I see in front of me is a quadratic equation. Again, when you have the graphics calculator, you can actually substitute this with a, what do you call it? You could actually just put in the graphics calculator and get the answer straight away. Now I'm kind of curious whether 11 is actually a common factor of these things. It is too. There we go. Yeah, so if you don't have a graphics calculator, you might have to do it the long method, which is take the 11 as a common factor and then factorize the quadratic. Luckily, with this question, you've got a nice 11 as a common factor, so you can take it out. But anyway, look, we're going to jump straight into equation. We're going to go into polynomial, degree 2, and we're going to punch in these numbers. So we've got negative 11, 528, and 3520. No, I made a mistake. Yeah, minus 3520. There we go. Okay, cool. That's much better. So we've actually got two values for t. So we've actually got t as 8, and we've also got t as 40. Right. So this is kind of interesting, right? Because like we've actually got two times here. And if you go back to the question, there's a little clue that's there in the question right here. So notice how it says find the rates of change of daily viewers. So we've actually got two times when the viewer number is actually 3,520. So keeping that in mind, the next step is actually to work out what v dash of t is. So we know that v of t is equal to negative 11t squared plus 528t, which means v dash of t equals negative 22t plus 528. So with that in mind, and we've got two times here, so we've got v dash of 8. So we're going to get negative 22 times 8 plus 528, which equals to, let's work it out, negative 22 times 8 plus 528. So that gives me 352. And then v dash of 40 is going to be negative 22 times 40 plus 528. So negative 22 times 40 plus 528. That's going to give me negative 352. So we've basically got two answers here, guys. And I know sometimes it's like natural instinct to go, oh yeah, it's actually we ignore the negative kind of thing. I know sometimes people do that, but like think about it like this, right? This is the rate of change, right? Basically what that means is that um, when it's positive, it's actually increasing, right? The rate is increasing. That means the number of people that are watching is actually increasing. When it's negative, it's actually decreasing. That's why it's still possible to have a negative rate, because a negative rate basically just means that things are decreasing. Um, all right, so let's have a look at what the schedule says. So seems fairly straightforward. Rate of change found. So that's the two rates that's found. You're going to get a merit, and then expression for dv/dt is going to get you an achieved. So that means a merit is when you do both of these things. The achieved is right there, which is v dash of t, which is also the same thing as dv/dt. All right, so let's go to the second part of this question. Okay, so the second part of the question is what is the maximum number of daily viewers that this presenter gets? All right, so that means we are going to get our v dash t, which we already did in the previous question, right? Because we did it as negative 22t plus 258. All right, that's basically from part one of the question. But the important thing is we're trying to find what's the maximum number. And if we want to figure out what the maximum number is, we need to differentiate and put it equal to 0. So we're going to put 0 equals negative 22t plus 258. We're going to rearrange this. So we're going to get 22t because it's negative and I bring it to the left-hand side, it's positive. I've got 258, and then t is equal to 258 divided by 22. So at this point, I'm actually going to get a value for t. So 258 divided by 22. Did I copy something wrong somewhere? Yes, I did. It should have been 528, not 258. Thought something wasn't right there. Let's try that one again. 528 divided by 22. There we go, 24. Much better. I knew it was like something's not right here. That's okay. We make mistakes where we can actually figure it out. All right, so we've actually got T is 24. But here's the thing. The maximum number of viewers is what they're asking for. So we've actually got to go back and substitute 24 in the original equation to actually work out what it is. So if you think about it like this, the original equation was, where is it? Minus 11t squared plus 528t. 11t squared plus 528t. I'm just going to copy everything right this time. Negative 11 times 24 squared plus 528 times 24. So this is going to be minus 11 times 24 times 24 plus 24 times 528. Of course, I just picked up that it's actually done that. Cool, there we go. So it actually gives us 6,336. So basically, guys, that is what we need to do for the second part of the question. So whenever you want to find a maximum for any kind of functions, you differentiate it, put the gradient equals to 0. That gives you maximum or minimum. In this case, we found out that t equals 24. And then you got to go back and substitute to figure out what the maximum or minimum is. So in this case, we figured out the answer, which is going to give us a merit. For the achieved part, it's just up here. All right. If you guys don't believe it, have a look at the answer schedule. It actually says derivative found and set to 0. Now the derivative, you already did it in the previous question. All right. So you already did it in that previous question. All you got to do in this case is just put it equal to 0, and that kind of covers your achieved there. So if you do see a question and you're like, maximum, minimum, remember, differentiate, equal to 0, solve, and move on to the next part of the question, all right? Cool. So let's go to question part 3. I think that's a lot to read. All right, guys. So what do we have here? So we've actually got a 10,000 viewers. When such stream reaches 10,000 daily views, it becomes monetized. Okay. Geez, I'm like reading through this question and I go, man, 10,000 daily viewers. Yeah, that'd be a dream. Anyway, let's have a look at this. So what we've got here is we've actually got a cubic equation, right? So that's the first thing to kind of keep in mind. So we've actually got a cubic equation. It's a positive cubic, which means it's going to look something like this. All right. So that much we know. So the question's asking, use calculus methods to determine if the stream, after it becomes monetized, ever stops earning money for the presenter. Okay. I guess the first thing you really want to be doing is have a look at the two, like the turning points. I would actually look at this turning point here and this turning point here. Mainly, I'm looking at that second turning point, because if that second turning point is above 10,000, then this person is going to continue making money, right? Because if that second point right here is above 10,000, then that actually means they're going to keep making money. So what we're really looking for is increasing function. So is the function actually increasing after that second turning point? So we're going to take our original function, which is 1.6t cubed minus 130t squared plus 2,900t. We are going to differentiate it. So when we differentiate it, we're going to get 4.8t squared minus 260t plus 2,900. All right, so this is basically the differentiated function right now. Now, as you can see, it's a quadratic, because what happens is that when we put this equal to 0, it's going to give us those two turning points. So that's what we're going to do. We're going to put this equal to 0, and we're going to get 4.8t squared minus 260t plus 2,900. And of course, at this point, what I'm going to be doing is I'm going to put it straight into the graphics calculator. All right. So go into your equation and go into polynomial degree 2. And we're going to replace with all of these numbers, which is 4.8 minus 260, 2,900. So when we press solve here, we've actually got two answers, all right? So the first one is 15.71, and we've also got 38.456. Now, here's the thing though, that is only giving us the time. So if I go back to my little graph here, I'm going to kind of put it up here so you can kind of get an idea of this, right? So this is the T, this is the number of viewers, and we're going between 0 and 48. So let's say this, I mean, I don't know, I think, yeah, T is equal to 0. Yeah, so it's going to probably look something like this, right? So what we've just discovered is these 2 points there. So that's 15.71, and then this other one is 38.456. We still need to know what the viewers are for these two times are. So we have to go back to the original equation, which is this one here, and we need to actually work out what V of 15.71 is, and also we've got to work out what V of 38.456 is. All right, so we got a little bit of substitution coming up here. So 1.6 times 15.71 to the power of 3 minus 130, 15.71 squared. Of course, I have to run out of space, plus 2,900 times 15.71. All right, so let's actually do this. All right, what do we got? 1.6 multiplied by 15.71 to the power of 3 minus 130 times 15.71 squared plus 2,900 times 15.71. Oh, that's a long time. But there we go, 19,678. So definitely above the 10,000 mark, right, at 15.71. So now we got to do 38.456. Now here's a little trick for you guys. Now I hate typing in these long numbers, right? So what I do is something like this. I put down 38.456 and I push this as put as enter, because what it does is like basically it stores answer as 38.456. Then I'm just going to go 1.6 multiplied by answer to the power of 3 minus 130 shift answer squared plus 2,900 answer. And there we go, 10,264 is what we're going to go with. I guess I'm just going to write this down, but sometimes just writing these numbers, it just takes such a long time, man. Squared plus 2,900 times 38.456, whatever. Here we go. So that gives us 10,264. I'm just going to round it up there. All right. Okay, so as you guys can see, this number is actually also above 10,264. Sorry, above 10,000. So if you think about it like this, so this is where 10,000 is. So that's where 10K is, right? But once this guy reaches 10K, he doesn't actually drop below that at all. So you can actually write a little comment to say something like, once viewers reach, viewers. Once viewers reach 10,000, you can actually say it never falls below 10,000. Okay, and also the other thing is, like, if you have a look at the this is something that we did in algebra, and sometimes we were looking at like the limits, like when is the function increasing. So if you look at it like this, the function is increasing between these 2 points, and it's decreasing between those 2 points there. So it's decreasing, right? So the way we can kind of picture this, and I think I would have done it here, if you look at the differentiated function, it is a positive quadratic. We've actually got 2 points here. The first point is 15.71, and the second one is 38.456. So it's decreasing because it's in the negative area here, increasing because it's in the positive area here. So you could write a comment saying that viewers are increasing when t is less than 15.71 and when t is bigger than 38.456. And you can also write a little comment, viewers are decreasing between 15.71 and 38.456. Okay, so grades wise for this question, I'm gonna have to kind of open up the other tab here to show you guys. All right, let's have a look. So these are the things that we did, right? So t-value of turning points found. So that's that initial part right there is going to get you an achieved. Now the coordinates of minimum point found, that's when you find like the two v-values. That's going to get you a merit. Now, as you guys can see, this is one of those double excellence questions, right? So I read through this and it says excellence criteria says one aspect missing. I guess when you call about aspects missing, I think they're actually talking about these parts here. So you've actually got to mention that you've got to mention this part, and I think you also got to do increasing and decreasing. Because it says for the second excellence grade, graph of function or gradient function. So this is where that drawing that I've done. So if you guys have a look here, notice how I did this drawing right here. So this drawing here is going to kind of help the markers see that you guys actually understand what you're doing. So as you can see, all of this is going to get you a double excellence point, which is, well, I shouldn't really say that, you get 8 points for it. And then for merit, this part right here is merit when you're finding both of these points. And obviously you need coordinates of minimum point found. So they're only saying 1 point. They're not saying minimum. Well, actually, no, minimum point is fine. So you just need one of them. T-values is going to get you an achieved. All right, cool. So that's basically it for question 1. All right, guys, so let's go to question 2A here. Now, these types of questions, there's always two of this, right? One where they ask you to draw the derivative, and the other one where they give you the derivative and ask you to redraw the original function. And interestingly, these questions, they always, they come up on one page, but trying to do this on like a screen that is 16 by 9 is quite tricky, but you know, look, this is the best I can do so far. So there's a reason why they actually do that, because what you want to be doing, and I'm going to try this, all right, because if it works, it's going to be brilliant, but if not, we don't really care. But like, this is pretty much how I do this as well. So I'd grab a ruler and see where all the turning points are. I would literally line that up. So if you think about it like this, so there we go. It's going to work. Yeah, I got it. There's my first turning point in red. You can kind of see it. This one is nice and simple. That's like the second turning point there. So there's my 2 turning points. And then my third turning point is right about here. Okay, cool. So that is kind of like the first things that you need to know when it comes to drawing differentiated functions, right? So you're always looking at the turning points and pulling out those 3 turning points. Now, the next step is to actually figure out what's actually happening between this. Now, some of you might look at this graph and go, geez, I got no idea what this graph is, right? Yeah, okay, if you have not seen it before, then that's kind of sad, but that's all right. We're going to look at this, and the way we're going to do it is we're going to take the ruler. So see how at this turning point, so we're going to have it at the turning point. But before the turning point, we're just going to take the ruler, and we're literally going to have a look at what's happening to the ruler. So the ruler, it's actually, the direction of the ruler is, it's actually going down, like, hang on. It's actually going down, right? And because it's going down, that means anything before this point, everything is actually in the negative section. So this is the negative section, and this is the positive section. So before this point, everything is going to be negative. All right, and we also have what's happening after this point. After this point, everything is kind of positive, all right, up till about here when it starts kind of like turning back and it's going to come down. All right, so it's kind of sick, but let's actually look at where else is it negative? Where else is it negative? It's also negative here at this point. How do I explain this? Because we've got 2 points where it's kind of changing through, just like somewhere here and here. All right, I'm going to drag that point. I'm going to kind of line it up there. No, should have done it in a different color. Maybe I'll do it in a highlighted color, actually. That way it's easier. So we've got those 2 points there where something is happening. And I mean, this is, again, these are rough things, right? They're not accurate. Let's see if this works. There we go. That's close enough. So what's really happening is this graph is kind of coming up, and then around this point, it's actually starting to slow down, and it turns around, comes back here, turns around, and does this. Now, if you are quite used to kind of equations, you would have seen like a parabola. This is a cubic. Of course, this particular graph is x to the power of 4. When we differentiate it, we're going to get something like 4x cubed, and x cubed shape is actually looking like this. So pretty much that is one way of doing this question, all right? So grades wise, what we're looking at is this actually ends up being a merit question. Partially because for the correct shape, so shape, if you have the shape right, you could get achieved. And then those 3 points. So I'm actually talking about 1, 2, 3. Those 3 points, the turning points, if you actually have it correctly mapped out in the diagram below, that gives you another achieved as well. But then if you have both of them correct, you pretty much get a merit and you could move on. And I want to show you guys the unscheduled one. Like look at the graph, all right? It is not perfect, right? Like when I look at my answer and look at this answer, it's not really perfect, but it doesn't really matter as long as you get the shape, as long as you get the shape correct and you get those 3 turning points correct, you are pretty much good to go. All right, guys, so let's go to question B. What do we have here? So we've got a function where x equals a gradient is to find the value of c. Okay, so we've actually been given what the f dash of x is. So we've actually been given that, sorry, f dash of 5. No, f dash of 2. So the gradient at 2 is equal to -5. So that's what we know. We've also been given f of x, and we need to figure out what c is. So I'm going to write down the equation as is. Then I'm going to differentiate the equation. So I'm going to get f dash of x, which is equal to 3 plus 2cx minus 6x squared. And because f dash of 2 is equal to 5, I'm going to put down 5 is equal to 3 plus 2c times 2 minus 6 times 2 squared. So I've got 5 is equal to 3 plus 4c minus 24. And I've got 5 is equal to -21 plus 4c. Of course, realize that should be -5 there, minus. So then we've got 4c is equal to -5 plus 21. So which can be written as 4c is equal to 16. Therefore, c is equal to 4. So another merit question here. C evaluated gets you a merit. Derivative found and equated to -5 gets you a achieved, which is derivative found. So I guess somewhere here is going to get you an achieved. Cool. Let's go to question 1C1. No, 2C1. So what do we have here? We got someone jumping off a cliff. Not the type of question you want to be seeing in the middle of the exam, but let's just say that they're adventurous. All right, so acceleration is equal to minus 9.8, so that's what it is. The diver jumps with an initial velocity of 2.8, so we could actually say that v of 0, so v of 0 is equal to 2.8, and we're trying to figure out the velocity of the diver 1 second after they jumped. All right, so we've got acceleration of t, which equals to minus 9.8. Velocity of t, remember that we have to integrate this, or anti-differentiate as some people like to call it. So we're going to get minus 9.8 t plus c. Now we know that the initial velocity was 2.8. So we're going to substitute v of 0 equals 2.8. So v of 0 equals minus 9.8 times 0 plus c. Now because v of 0 is 2.8, we're going to get 0 plus c, and c is equal to 2.8. So a velocity function is equal to minus 9.8 t plus 2.8. So at velocity of 1 second, so we're looking for v of 1, which is minus 9.8 times 1 plus 2.8, which actually gives us minus 7. 9.8, and yep, that's going to give you minus 7 meters per second, all right? So find the velocity of the diver 1 second after they jump. So after 1 second, their speed is minus 7. There we go. Grades wise, velocity found is going to get you a merit. Anti-differentiated, including constant of integration, is going to get you achieved. So basically that means you need to actually differentiate and also have the C, the letter C in there to actually get that achieved grade. All right, so let's go to the next question. And I believe this is a double excellence question again. Let me just have a read through this. Okay, there's a couple of ways of doing this particular question, and I'm going to go with the more standard, traditional way of doing this without readjusting anything. So if you think about the diagram there, right? So we've got the cliff there, and the guy is kind of like jumping down. So these are some of the things that we actually know. All right, what do we know? We know the velocity of t. We know what v of t is, right? So v of t is equal to negative 9.8 t plus 2.8. Now this is from the previous question, I believe. Negative 9.8. Yep. That's all good. So this is what v of t is. So we know that he hits the water. So right there. Oh my God, my stick figures are awful today. Just trying to do this. There we go. So when he hits the water, it's at negative 22.68. So we're going to figure out at what time that happens, all right? So we're going to put down negative 22.68 equals negative 9.8 t plus 2.8. So rearranging this, we're going to get 22.68 minus 2.8, negative 9.8 t. What is this going to be? Where's my calculator? Clear. So we've got negative 22.68 minus 2.8, which is 25.48. And of course, t is equal to negative 25.48 divided by negative 9.8. Cool. So this is going to give me t is equal to 2.6. Okay. So what we figured out is, let's just kind of draw this up a little bit. Give me 1 second, guys. Just going to drag this equation out here. So let's actually put some facts down here. So this is when t is equal to 0, and then this is when t is equal to 2.6. So his initial speed was 2.8, but that really doesn't matter at 0. And then at 2.6, his speed is minus 22.68. What we want to know is we want to actually figure out what the distance is at 0. And we also obviously want to figure out the distance at 2.6. So we're trying to figure out S of 0 and S of 2.6. Now we know what S of 2.6 is. S of 2.6 is actually equal to 0 because at 2.6 seconds, the guy's actually landed in the water. So that means he's already at ground level, right? S of 0 is actually going to give us his starting point, which is actually the height of the cliff. So that's what we need to do. We need to actually work out what S of 0 is. So let's go back here. And what we're going to do is the first thing is we've got V of t, which means we can actually work out S of t. So S of t is integration or anti-differentiation of this, t squared plus 2.8t plus c. So we know that S of 2.6 is equal to 0. So with that in mind, we're going to substitute 0 equals negative 9.8, 2.6 squared over 2 plus 2.8 times 2.6 plus c. So let's actually work this out first. So we've got negative 9.8 divided by 2 first. It's negative 4.9 multiplied by 2.6 squared plus 2.8 times 2.6 equals negative 25.844. So this is negative 25.844 plus c. So we can actually then say c is equal to 25.844. Okay, so now what we have is we actually have S of t, the distance formula. So we actually have it as minus 9.8 t squared over 2 plus 2.8 t plus 25.844. So at this point, I'm going to substitute S of 0 because that's what we're trying to figure out. Now this whole term is going to become 0 plus 25.844. So we can actually say, therefore, height of cliff is 25.844 meters. So, looking at the marking schedule, what do we got? Correct answer with some, I don't know what this word IMS means. Need to look it up. Correct answer with clear, correct statements. That's going to get you an excellence. And of course, this is a double excellence. Merit is time of impact found, which is the 2.6, or time of maximum height. I don't understand how to, I think that's a different way of doing it, so we're going to skip away with that. Anti-differentiation to find h of t with unknown constant of integration gets you achieved, which would be that. That's going to get you achieved. Right. Bit of a weird question too, because there were 3 merit questions and 1 excellence question, and that's it. We go to question 3 next. All right, guys, so let's go to question 3. 3A it is that we're going to get started with. So what we got here? Well, we've got the classic one. We've got the anti-differentiation question here. So this curve is passing through 1, 2.5. Find the coordinates of the point f of x where x equals to 2. Okay, so we've got f dash of x, which is 6x squared plus 5x minus 1, which means f of x, we got to integrate or anti-differentiate it, as some people like to call it. We got 6x cubed divided by the new power plus 5x squared divided by the new power. And of course, we've got minus 1x. And of course, don't forget the plus c. So f of x then is equal to 2x cubed plus 2.5 x squared minus x plus c. So what we've got here is the point f of 1 is equal to 2.5 because this point actually goes through this curve when x equals to 1, right? So we've got to actually work out what c is. So 2.5 is equal to 2 times 1 cubed plus 2.5 times 1 squared minus 1 plus c. So we've got 2.5 is equal to 2 plus 2.5 minus 1 plus c. From here, I can kind of see that those two 2.5s is going to cancel out each other. And I've got 0 is equal to 1 plus c, or c is equal to minus 1. Now, once I've figured that out, I've got to go back and substitute 2 in my f of x to figure out what the y value is. So then f of 2 equals 2 times, so I'm going to write the equation of f of x first. So f of x is 2x cubed plus 2.5x squared minus x minus 1. So I've got to figure out what f of 2 is. So f of 2 is 2 times 2 cubed plus 2.5 2 squared minus 2 minus 1. And I'm just going to chuck this all in the calculator here. So what do we got? 2 times 8 plus 2.5 times 4 minus 2 minus 1. So that gives me 23. So then the coordinate is going to be 223. So grades wise, this is coordinates correct is going to get you a merit. Anti-differentiation correct apart from constant term. So that's going to get you an achieved right there. Okay, let's go to question B. So question B, what we've got here is velocity is this. How far is the scooter from the sign when t is equal to 3 seconds? So if velocity equals to 0.3 t squared plus 1, then we can say that the s of t is 0.3 t cubed over 3, which is the new power, plus t plus c. Now, because this question is actually asking us how far is the scooter from the sign, we can kind of assume that at the sign, from the sign, right? So that means we can say t is 0, s is equal to 0, which means therefore c is equal to 0. So what our equation for our distance is going to be 0.3 divided by 3. That is, talk about, sorry, I think, see, this is a problem, right? I'm like doing multiple things at the same time. It's a terrible thing to be doing, especially when you're doing a video. Anyway, so we've got 0.1 t cubed plus t is our s of t function. T is equal to 3 seconds. So after 3 seconds, we've got 0.1, 3 to the power of 3 plus 3. That's going to give me 2.7. 0.1 times 27, that's going to give me 2.7 plus 3, which equals to 5.7 meters. Interestingly enough, this question is actually only worth an achieved, even though you're integrating and you're solving. Yeah, it's weird. Anyway, let's go to the next question. Now, here we go again. This is the reverse of this question, right? So the diagram below shows the gradient function. And what we have asked to do is obviously find the f of x. So with that in mind, here's a quick little hint for you guys, all right? So this is a minus x squared, all right? This is a minus x squared because it's a negative parabola, which means when we integrate this, we're going to get a negative cubic. So we already know that this shape of this negative cubic is going to look like this. All right, so that's something that we already know. The next thing is we've got a couple of turning points that we need to kind of track, which is we're going to take this ruler again, and this is going to be my best attempt, guys. I do apologize. Can I move it a little bit? A little bit. There we go. See, I don't know how to draw this line. I keep trying and it's just not working, but maybe I'm going to try with the highlighter. Oh, yep, that works. So that's my first turning point. And then my second one, right, this would actually help if my diagrams are actually lined up. Let me just pause for a second. Yeah, I didn't actually line up the diagrams properly. That's why it's looking a bit kind of clunky here. So basically what this tells me is that this turning point right here, this turning point is going to be somewhere here. And then of course we've got the next turning point, which is this, and this could be somewhere along this yellow line somewhere there. All right. So apart from that, I don't think there's any other information that we've given to us to kind of help us with this. So we're just going to kind of roughly do a sketch. There we go. And I think we should be all good with that. So basically, I'll show you guys the answer schedule. As you guys can see, that turning point happens at 2 and kind of like further down. You've got the negative cube. They're saying red curve, accept any intercept with axis, so it doesn't really matter where it cuts the y-axis. Or the x-axis, it doesn't matter where it cuts the x-axis. The only thing they want to be looking at is the negative cubic shape and turning points correctly located. So kind of like that's that yellow line that I just drew to highlight the turning point. If you just get the negative cubic shape, you get an achieved. And if you get like the points, the turning points correct, you get an achieved as well. So keep that in mind. So this right here is going to be merit. Not bad for this one. Okay, so let's go to question D. Lots to read again. All right, guys, so with this question, what we've got is we've got to find the maximum area, right? Find the height of the wall and justify that this is a maximum area. Jeez, that's a lot of work to do, but that's all right. We're going to try and show you how to do this. I guess the first thing you really got to do is come up with the, just like the generalized equation for this, right? So what do I mean by that? So let's actually break this down. So I'm going to have to kind of draw this separately so that you guys can see this. Let's go X and Y right there. And we're going to have this parabola that looks like this. You might be wondering, why do I need to do such a big one? But like, trust me, it will make sense. All right, okay, terrible, terrible house, but you get an idea. So first off, I'm going to look at just the rectangle, right? So the rectangle, what I've got here is the base of the rectangle here is actually going to be 2x because it's x on one side and then the other side, because it's reflecting on the other side, it's going to be minus x. So we can actually say the base of this rectangle is actually 2x. Now the height of the rectangle is anywhere along that green parabola, right? Now the green parabola is the y value. So imagine like this. If I take this point right here, this is xy. This point right here is xy, which means the height is actually y. So what I've got here is the area for rectangle, which is base times height. The base is 2x multiplied by height, which is y. So this is my rectangle's formula. And remember, I'm trying to find the maximum area for the total of the two things. So I've got to do rectangle plus triangle. Now with the triangle, I've actually got half times base times height. Now the good thing is the base of the triangle is also 2x. All right, so that's all good. So we can actually go half times 2x, which is the base. But we've actually got to figure out the height of the triangle. Now what we do know is it actually says point C is at 0, 9, right there. All right, So this point right here is at 0, 9. So if this is 9, then how do I put this? So I'm going to kind of break it down a bit further here so you can kind of have a look at here. I want to know, because the height of the triangle is this distance right here, all right, that I've highlighted in light blue, that's the height of the triangle. The height of the rectangle is actually in pink. I hope that makes sense right now. And this whole distance from the top to the bottom, which is highlighted in red, is actually worth 9, which means the light blue part is going to be 9 minus y. Because you guys can see that the red part is actually blue part plus the pink part. So if we want to work out the blue part, we can actually say 9, which is the red part, take away the pink part, which is 9, take away y, is going to give you the blue part. So the height of the triangle is 9 minus y. In fact, I think this is the most hardest part of this question itself. It's coming up with that general equation. Because once you come up with the equation, then we can actually say area, total area, equals rectangle plus triangle. Rectangle is 2xy plus triangle, which is a half, multiplied by 2x multiplied by 9 minus y. Now, interestingly enough, we've got 2's here that can cancel out each other, and we're left over with 2xy plus 9. No, we've got x times 9 minus y, isn't it? Yep. X times 9 minus y. So this is now the area. But what we also know is that y is actually equal to 9 minus x squared. We know this from right here. So what we're going to do is we're going to replace the y with 9 minus x squared. So we're going to rewrite the area equation, but this time with no y. So we're going to get 2x, 9 minus x squared, plus x times 9 minus x squared. Cool. So with that in mind, what I can do is now expand the brackets. So I've got 2x times 9, which is 18x, minus 2x cubed, plus x times 9 minus 9 plus x squared. I'm taking out that bracket first. Then I've got 18x minus 2x cubed plus x. 9 minus 9 is 0. This is x squared. I've got 18x minus 2x cubed plus x cubed. And this all simplifies to minus x cubed plus 18x. All right, so this is my formula for area, the total area. Now, if I want to figure out what the maximum area is, I need to differentiate it. So when I differentiate the area function, I'm going to get minus 3x squared plus 18. Also remember that area is max or min. Well, a turning point is happening, right? So we're going to say when area dash equals to 0. So we're going to put 0 equals minus 3x squared plus 18. We're going to rearrange. So we've got positive 3x squared equals 18. X squared equals 18 over 3. And we're going to get x squared equals to 6. Therefore, x is equal to square root of 6. Now, what this is actually telling us is that when x is equal to square root of 6, that's when the maximum area is going to happen. Now, remember, I did say earlier, like max or min, right? That's because I was thinking about turning points. In this case, the minimum area is, it's going to be something else, because can it be 0? Let me just have a quick think about this. No, not really. I think the triangle, yeah, the triangle is always going to be in the corner, so you're not going to have a minimum, you will have a minimum area of something. That's all right. Let's just work out what it is, because what do we need to work out? We need to actually find the height of the wall, which is AF or BE. So we're actually looking for y, because y is the height of the wall. So y is equal to 9 minus x squared. So we can actually say y is equal to 9 minus x squared. Because that's the height of the wall, we're going to get minus square root of 6 squared. We're going to get y is equal to 9 minus 6, and then y is equal to 3. So we can then say height of wall is 3 meters, or 3 in this case. I'm just going to put it as 3. Now the next part is that if you go back to the question, it actually says justify that this is the maximum area. All right, how do we do this? So we actually have area dash. And again, this is where you guys can actually do double differentiation and actually just work out what square root of 6 is. All right, and I think I've done this before with proving when it's a maximum or minimum point, is you double differentiate, substitute the x value, and find out what's happening here. So I'm going to double differentiate area, which means area dash. What was area dash? Area dash was minus 3x squared plus 18. So when I double differentiate it, I'm actually going to get minus 6x. And I am going to substitute when x equals to square root of 6. I'm going to get negative 6 times square root of 6. And because this is a negative number, and I can say this, since area double dash of square root of 6 is less than 0, this is a maximum. This is a max solution point. I'm going to put max solution. All right, and what I will show you guys is like, as you guys can see in the answer schedule, they've actually given out like quite a few little bullet points. So some of you might have not done double differentiation. You might just go, well, look at the graph and then try and work from the graph. Yeah, double differentiation is easy, man. Like just try and learn that, and then substitute the value. If it's negative, then it's a maximum. If it's positive, the double differentiation that I'm talking about right here. So notice how this is like negative 14.7, which is less than 0. So it's a negative number. That means it's a maximum. That's when a maximum occurs. And if it's positive, it'll be a minimum. Much easier to kind of do this in the exam than to try and kind of like tinker around with these things and trying to write like reasons. Cool. So grades wise, what do we got? Height of wall clearly stated and justification. So you do need justification from something, whether it's second derivative. As you guys can see, there's quite a few options here. So if we go back to our answers here, this right here is going to be worth an excellence. So you need the height of wall and this to get an excellence. For a merit value of x and or y found. Okay, so this is a merit. So y or x. Achieve their area expression differentiated consistently. All right, so here's an interesting thing, right? So I'm going to go right here. Let's say you make a mistake here, but then using your wrong mistake and you come up with the correct differentiation, then you can still get an achieved for it. All right. So even though you get the equation wrong, I mean, potentially think about it. Like you look at this question and you're like, oh, I got no idea where to start from. You come up with some random equation, and if you consistently differentiate it, you could still get an achieved for it, which is interesting. But yeah, it is. That's NCEA. Welcome to NCEA. All right. So let's go to the last question. The last question for generalized problem. Where show the Okay, so with this question, what we have to do is we've got to generalize one, all right? So we've already got the equation, which is good, and we're going to kind of use that equation. And it basically says that the show the maximum area occurs when the rectangle's area is equal to the triangle's area. So that is quite a lot of work, is it? Not really, because let's think about it, right? Our original equation that we came up with was, if we go back, the simplified version was, no, we can't do the simplified version. We're going to use this version right here, the 2xy and x9 minus y. So let's use that. So we're going to go 2xy plus What do we got? Plus, what did I miss? Kind of missed that. X9 minus y. But here is the issue. The issue is C is no longer at 0, 9. Remember, this is now at 0D. So that means you can't really have a 9 there, which means you're going to get rid of this 9 and replace it with a D. Cool. So exactly what we're going to do with what we did in the previous question. Now we're going to replace y with d minus kx squared. So we've got a is equal to 2x, and instead of y, we've got d minus kx squared plus x bracket d minus kx squared. Okay, so now we need to kind of expand this quadratic, or expand the brackets and just simplify it. It's not really quadratic. So we've got 2xd minus 2kx cubed plus x, d minus d plus kx squared. We've got 2xd minus 2kx cubed plus x, no, kx cubed, because the two d's disappear. And our final equation should be area equals 2xd minus kx cubed. Okay, so what we've got here is area equals to that. So we're going to differentiate area a dash. So we're going to get 2d minus 3kx squared. 2d minus 3kx squared, yep. And then we got a dash is equal to 0 for max. So we're going to go through here next. So we can say that 0 is equal to 2d minus 3kx squared. And then I'm going to rearrange. So 3kx squared to the left-hand side becomes positive, equals 2d. And then x squared is equal to 2d divided by 3k. And of course, then I can say that x is equal to square root of 2d over 3k. Now, this is what x is equal to. All right. I still have not shown what the area is now. I'm just wondering whether I can do a shortcut here. Just give me a second. So guys, at this point, what you could do is you could actually work out what the y value is and kind of work through again. But I am going to do a shortcut here. And the way I'm going to do the shortcut is because I already have area of the rectangle. The area of the rectangle is this right here. All right, I'm trying to avoid figuring out why. I'm trying to do a shortcut. And the area of the triangle is this one here. Also simplified to, we could probably do it here. Now, it doesn't matter which one you choose. I mean, you could actually choose that one, but I would actually stay away from that, and I'll show you why. I'll probably use this as for my area of a triangle. So let's actually work out what the area of rectangle is. So area of a rectangle is equal to 2x d minus kx squared. All right, so this is area of the rectangle. So because x is equal to that square root symbol, I could rewrite this as 2 multiplied by x, which is square root of 2d over 3k. And in the bracket, I've got d minus k, and then I've got x squared. Now this is x, 2d over 3k, and that is squared. Now this is quite an ugly looking equation, but trust me, it's still going to work out in the end because we're going to match the two things up. So we've got 2 square root of 2d over 3k. In the bracket, we've got d minus k. Now that's square root and squared, which basically means that square root symbol is going to go away. We're left with multiplied by 2d over 3k. At this point, my 2k's are going to cancel out, and I'm left over with 2 square root of 2d over 3k. In the bracket, I've got d minus 2/3 of d. Now remember that this is actually 1. 1 take away 2/3 is just 1/3. So in my bracket, I'm going to write this as 1/3 d or just d over 3. So I've got 2 bracket 2d over 3k multiplied by d over 3. So I'm going to leave it like that for now, all right? Because, I mean, I don't need to simplify it really a lot, because if I can match the triangle one to this, then I should be all good. So next, I'm going to work out the area of the triangle. All right, so that's the blue highlighted part. And as I said to you, I'm going to use not the x cubed, the kx cubed one. I mean, we could use it, but actually let's use the kx cubed, and I'll show you a couple of tricks as well. So that's the area of the triangle. But here's the thing. I can rewrite this as, I don't want to put x cubed in there because I know that x has got a square root symbol. So I'm going to redo this as k times x multiplied by x squared. So then I've got k square root of 2d over 3k, because that's what x is, multiplied by square root of 2d over 3k squared. And because that has actually got a square in it, the square root is going to disappear, and I'm left with just 2d over 3k. And remember, all of this is getting multiplied. So because it's getting multiplied, I can actually cancel out the 2k's, and I'm left with just 2d over 3 square root of 2d over 3k. And if you look at it on this side, I mean, that's pretty much what I've got here. I've just got the d over 3 on this end. I could just move it in front of the square root symbol, and I'm going to end up with the same answers. All right, so I can actually see that both of these areas are equal. So I could actually say area of rectangle is equal to area of triangle. I have to say, I mean, I think this is quite a horrible proof question to be given for an E, for like one excellence question compared to the other questions that you guys have seen so far. I mean, like, I looked at the previous excellence questions and they were like, oh yeah, that's pretty straightforward. But this one, it's just a lot more algebraic manipulation than I would like it for a calculus question. But you know what? That is what it is. Separately and shown to be equal. So this is going to get you an excellence grade right here. Value for x or y found is going to get you a merit. Now, obviously, I skipped the y value completely and I just went straight to the area equation. That's just trying to save time, guys, because I mean, you could calculate y and you're still going to end up with the same kind of expanding thing. I don't know, maybe it might be been a bit easier. Relationship formed and correctly differentiated is going to get you an achieved, which is up to here. Have a look at the marking schedule here. And so as you guys can see, what they did was they kind of worked at max, they worked out the x value. Once they worked out the x value, they then worked out the y value, and then they substituted in, and it doesn't matter whichever way you go, you're still going to end up with like ugly looking equations. That is part of this particular question. Cool. So overall, the paper wasn't actually too bad. I mean, apart from that last excellence question, most of the paper was pretty nicely done. So my kind of little tips for you guys, if you do have any questions or things that I probably missed up, just pop it in the comment section below. As for you guys, as you're preparing for this paper, just make sure that you attempt every question. Do not leave anything empty. It's just, how do I say it? Like sometimes you'd be surprised at what you get an achieved grade for. All right, so do not leave the question paper empty. Attempt all the questions if possible. What else? I'm sure I'm going to say this again, but like probably a little video will pop at the end of this. But guys, I would love for you guys to subscribe and let people know about this channel, because a lot of people don't actually know this channel exists literally on the night of the exam. Because that's what people are like. So yeah, pass the word around, and of course subscribe. Yeah, something should pop up. That's probably the right message. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, And of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.